increasing, decreasing, maximum, minimum, lots of different things like that. So I'm not going to go through a whole lot of those kind of things. Those are all things that we've seen pretty recently. I think the biggest thing that was missed a lot on the quiz is just paying attention to, if we have operations, like on number 8, this is just a multiplication problem. And what I would tell you on number 8, there's 2 ways to do this problem. You could try to multiply these two together. That's going to be the long way to go, because you're going to have to take x minus 1 times this, and you're going to get this big old long polynomial. That's probably not the way I would go about it. The best way to go about this one is to take -5, plug it into f, take -5, plug it into g, and then multiply your 2 answers together, okay? That's going to be your best option to do that one. So I think that would be the quicker and easier way to go. When you get to like number 9, I know a lot of you would do it like this, where you would do x squared plus 4 plus 5x minus 2, which is fine. And you could kind of do the multiplication one the same way, but because we have a number to plug in here, now we can go ahead and plug it in, and kind of like we just talked about on number 8, then you're just going to put the 2 answers together after you take 5 and plug it in. (10, 11, and 12 are basically the same thing, except you got x there. There's no number to plug in there. The one thing that was missed the most on the quiz is on number 12. This was missed quite a bit. Take the time to write it out. Also, make sure you pay attention to the order that it goes in. Sometimes it could be f minus g, sometimes it could be g minus f. Those are not the same thing. And so really pay attention to what comes first, what comes second, and write it out like this. If you don't take the time to write it out like this, you're probably going to miss it, okay? Because now what I'm going to see, and parentheses are a big thing here as well, I got to take this minus sign and I got to distribute it to that second parentheses or second function. And so how you write those things out is a really big deal. And remember, like 10, 11, and 12, your answer will be an expression. You're not going to have a number for your answer because you're doing it with x, not with a specific number. 13 and 14, those are your composition problems. Just remember to work backwards. Like 13 is f follows g, so I plug 2 into g and take that answer and plug it into f. You only use 2 one time. You take 2, you plug it into g. So I'm going to plug 2 into here, and I'm going to get this answer, and I'm going to plug it in to that. Okay, you don't have to take the whole function and plug it in. I mean, you could do it that way, but I think that would be the longer way to go about it. There's a couple of different ways to approach some of these. 14 is different because it's g follows f. So I'm going to take -4. I'm going to plug it into f first, get that answer, plug it into g. So just really, really be careful of your order on ones like that. Okay, and then you got a couple of composition ones that just ask for no certain value, no number. We're just going to put in x and put a function into another function. And continue to pay attention to the order. What one goes first, which one goes second. Hey, starting with 17, this is the things that we've talked about this week. On Monday, we talked about all of the different types of symmetry with x-axis, the y-axis, and the origin. And so here you have some graphs, and you have to determine what type of symmetry you've got. And there's several different things listed here, so you just have to figure out which one. Pay attention, because like sometimes it could be more than one in some cases. But those are multiple choice. You just have to decide what type you have. It's just a matter of looking at it. Okay, on this one here, as far as the test goes, then you got to show me a little bit of work, okay? You got to show me what it looks like algebraically. So you're going to go x-axis. You're going to go y-axis. Plug in the opposite of x. And then you're going to plug in the origin. So you just have to show me a little bit of work to get the credit there. Doesn't take a whole lot of work, but you just have to plug it in and then show me, does it get me back to the original or not? And tell me what type of symmetry you've got going on there. Okay, 20 and 21, we talked about some of these on Monday. They give us an ordered pair, and they want us to talk about what would be symmetric to the y-axis. And so all that means is if I take that point and reflect it over the y-axis, where would it land? And there's two ways that you can kind of go about this. If it's the y-axis, the rule is the opposite of x. And if you can remember that rule, that's all you would have to do. I'm going to take this point and I'm going to flip my x value, so it's now going to become negative 1.5. Nothing happens with the y value. And so that one would be A. If you would rather do a graph, you don't have to be real specific about where your point is. Okay, 1.5, 1.75 is going to go right and up. Okay, if I flip it over the y-axis, I'm going to flip it over into that quadrant. And just remember, like, this one's positive, positive. And so when I flip it over here, my answer has to have a negative and then a positive. And there's only one answer that has a negative and a positive, which is A. Okay? So you don't necessarily have to, it's just a visual more than anything. When I flip over the y-axis, my point is going to land in this quadrant. And that's the point I'm looking for. So if you're a visual kind of person and want to do it that way, you could actually flip it over the y-axis, or you can just remember the rule. And remember, you have to do the opposite of x. The x-axis is the opposite of y, and the origin is the opposite of both. And that's kind of like what we talked about up here. Here's your three rules for your symmetry. On 22, just remember that even is symmetric to the y-axis. Odd is symmetric to the origin. And what we talked about on Monday was, the way I remember it, odd and origin. Okay, kind of an easy way to remember it. So is it symmetric to the y-axis? Is it symmetric to the origin? And if it's neither one of those, then we would say neither. Those are your only three options: odd, even, or neither. All right, and then the last group of problems, 23 through 29. Most of these, and it seems like a lot of questions, but a lot of these are just kind of looking at the problem and trying to decide which one fits it, okay? Like, for instance, on number 23, we want to identify two things. First of all, the x plus 9 under the radical, we're comparing it to my original function, absolute value, or square root of x. What's the plus 9 going to do here to my graph? Which way?
Go up.
Because it's on the inside. It's on the inside. If it was after the function, if it was after the radical, it would go up 9. It's going to go opposite. So it's going to actually go left 9. Okay? So the plus 9 is under the radical, then it's going to go left or right, but it's going to go opposite. So it's going to go left 9, and then you do have a negative out in front here, and that's going to reflect it over the x-axis. So there's two changes that are happening here. Reflect the x-axis, and it's going to shift horizontally 9 units to the left, and so B would be the best I know that sometimes when we look at multiple choice, we think, oh, this is going to be a lot easier, but you got to make sure you read them carefully, and all of those options are really, really close to one another. And so you got to make sure you're careful with that. On 24, all you have to do is just tell me what type of change is happening, okay? And here there's two changes that are happening. So just tell me, what are the 4 and the 5 going to do to that function, and what direction are they going to move it? You just write that on the blank. 25 is kind of like the one we did just a second ago. We did a couple of these yesterday where I give you an ordered pair, and you have to decide what's going to happen to that point. If that point is on that function, is it going to move left, right, up, down? What's going to happen to it? And then think about which value is going to change. Is my x value going to change? If I move it left or right, my x value will be different. If I move it up and down, my y value will change. 28, you're actually going to write a new equation that fits these two descriptions. And then 29, match the equation with what's happening. So sometimes they give us the equation, we have to identify what's happening. Sometimes they tell us what's happening, we have to write the equation. So both ways. Okay. All right, I'm going to let you guys work. If you have any questions on anything, I did post answers to 2.6 and 2.5 last night.